guys. How are you? Nice to see you. Come on in. We'll get you to the front here. You see, that's what the problem is. You come late. You put you in the front, right here. Now we can see it. Thank you. Thank you for coming.
You want to take a few pictures? Hi guys. Good, thank you.
We take this picture.
Yeah. Stop.
Hi there. Hi. How are you? All right.
Like you want something nominated? So you get a selfie. Get out of the robot and he doesn't even know it. Shots and back shots and this is the good side. There it is. Oh, perfect. Perfect.
Okay. Wow, right on time. Good morning, guys. So great to see familiar faces. My name is Chad Purdy, and I teach electrical design here at Dunwoody for the last 12 years. What we have today for you guys is a lot of you are graduates and you're familiar with the program, but Dunwoody has an electrical program, electrical design program. And part of restructuring, lately, last year we did restructuring, we moved into from quarter to semester. So part of that move from quarter to semester, we merged the first year of ECDM, the electrical design, with the first year of the electrical construction. So we only have right now 1 year of electrical design because all the fundamentals and the wiring, we teach them with the electrical construction students. So what we look at in the second year, we have 3 projects like we've done in the past, 5,000 square foot apartment building, and we do residential, lighting, power, and low voltage. And we still run a 10,000 square foot commercial building adopted by Lundberg engineers, so thank you, for the last 14, 15 years or so. So that project is 10,000 square foot office building, so we do it in Revit. The residential project is in CAD, we still do CAD. This project that you will witness today is done in Revit, 10,000. We do the lighting, the power, the low voltage in Revit with all the NEC calculation 2011 associated with it. And we do energy code. You're going to be introduced. They do energy code for the lighting. They do, believe it or not, SCM, power system analysis, short circuit, and they do load flow, and they do arc flash calculations. Now, don't ask him to interpret yet. It's the first time they ever use the software, but they know how to run it. So in front of you guys, the agenda for the day. We have 5 teams, 5 students, 5 teams. We had a hit because of the transition from quarter to semester. So this is the smallest class I ever had since I've been in Dunwoody in the last 12 years. The good news is we do have a bunch of first-year students sitting right there. We have 8 of them coming. And we anticipate to pick another 2 from the electrical construction or more. So we'll be in the 2 digits next year. So that's the good news. So if you're looking for internship in the summer, they're sitting right there. If you're looking to hire in the spring, they will be presenting today. So I have the agenda for you guys right here. And in front of you also, like we've done in the past, what the teams are going to be presenting on. I was telling a few people here that, like I did this one for 11 years, this project. This is the first time I ever run it where every individual have done everything. So because it's 5 students, they did every single thing. No teams. They can help each other, but there is no team. So what you're going to see They're going to present certain parts of it, but they did every single part of the project. And the MC, our MC, we'll talk about this one here. I do have an evaluation sheet, guys. Please, if you take a second, the last sheet in front of you is a little eval sheet. If you can, oops, you have it. The little eval sheet, guys, that if you can, I grab you here. If you can just give him an evaluation, 1 to 10, 10 being the best. So, okay, with this, I would like you guys to enjoy the presentation. I'm going to introduce my friend Derek here to lead the presentation. Thank you.
All right. I just wanted to say good morning to you guys. How are you doing? Thanks for coming out. I just want to thank you for coming to the commercial project presentation today. We want to start by thanking Chad for being a great instructor this year and helping us prepare so well for working in history. So, like you mentioned, we are a small class this year, and due to this, we did not break up into teams. So we do feel like we had a great opportunity to do every aspect of the project and hopefully give you a fresh, knowledgeable take on this project. So with that, what I'm going to do here is introduce our first speaker, Adam Custerman. He's going to be presenting for us today, so he'll be doing our one-line and power system operations. Adam likes to play golf. He'd also like to see the Minnesota Twins win a World Series. We'll likely be dead before that happens. So, with that, let's give it up for Adam.
Morning, guys. Alright, so with the title sheet, we just started out basic stuff. Engineering firm at the top here. Engineering firm, electrical company below it, architect, and then the manufacturing company, and then Lundberg Engineering Building. Picture of the commercial building of Lundberg. Symbols, E2. Grabbed this. This was just a family we grabbed out of Reddit. Polarizer E3. Showing the generator, the ATS and CT on the left side with the main panel, lighting panel on the other side, with the feeder size is 500 amp, and the receptacle panel 100 amp, and the lighting panel 200 amp. The lighting and power E4, the site plan, showing the outside lights along with the lights on the outside of the building here. Lighting E5. Derek will take you more in depth on how this goes. Alternative. This is the first year we've done alternative lighting, and this is in the open office. Floor plan power E6. This will be run by Brian. Brian will introduce this more. Floor plan systems E7. And Karen will introduce this more in depth. Low voltage systems riser E7.1. And the panel schedules. Brian will take you in depth again on this. Equipment, lighting fixture, and control panel schedule. I took a snippet of this, and you can probably tell I can't really see anything in here. That's just with it came from AutoCAD, from the AutoCAD drawing. This is the control panel. Details. Details diagram, just some basic details on the generator concrete pad, trench detail, and pole base. And just a few symbols I want to show. In the electrical room, we have the air handling unit, the recirculating pump, the gas boiler control circuit, along with the two boiler pumps, and then your basic receptacle, ATS, main panel, receptacle panel, lighting panel, and then right next to the lighting panel is the lighting control panel. The heating, and then the heating unit right here, along with the fan, and then with that, on the air handling unit is the VFD. One line diagram from SKM. Normal power comes in to the ATS and feeds the main panel to the lighting panel, receptacle panel, air handling unit, two condensing units, one condensing unit, and then the future, and then the two boiler pumps. And then if the normal power fails, ATS switches over to the gen turns it on and backs up all the equipment. Cut sheets, main panel, 100 amp main panel, lighting panel, 200 amp, receptacle panel, 100 amp, ATS, generator, and with that, I want to bring you guys into the load calc. Load calc. We did the load calc from in the Microsoft Excel. Everything from receptacle load in Article 220.14L, and that's non-continuous. Fixed multi-outlet assemblies, and your office, your largest of the line, unknown receptacle load. Size the receptacle panel with the receptacle neutral, lighting panel with the lighting panel neutral. The general lighting load, largest on the lighting load, along with track lighting, sign and outline lighting, parking lot, and then down from that is the motor. Motors took from 430 size all the motors, and then took the largest by 0.25, and we came out with the main panel 500 amp, receptacle panel was, like I said, 100, and the lighting was 200. Two sets of 350 kcm, and the receptacle and lighting panels were two sets of 3-aught. And that's presentation. Thank you.
Does anybody have any question for Adam? Put him on the spot here. Ran away from the question. Anybody has any questions? Any comments? No?
Okay, let them off easy. All right. We have our next speaker is going to be Brian Lundberg. And like you said, Brian's going to be showing you guys the power layout and everything for the commercial building that we have. Brian enjoys long walks on the beach, and Adrian Peterson, the last of which just violated his restraining order. So we'll hand it over to Brian before the cops arrive.
Like Derek said, I'm Brian Lundberg. I was team number 5. I don't know if that matters. But, let's see. If you're ready. All right. Think we're good. Yeah, I'm going to be talking about the project schedule. I'm going to be showing you a little bit about the mechanical equipment layout and circuiting. Adam already did just a little bit of that. And I'll also be showing you the power layout and circuiting for the building, as well as the main panel and receptacle panel schedules. And I'll be showing you the cut sheets that I have for the main panel, receptacle panel, and our automatic transfer switch. So as you can see here, this is the project schedule. We use Microsoft Project to do this. This is kind of the schematic design phase that we had, meeting with the owner and the utility company and putting together a one-line diagram prior to going into the actual design phase. You can see here, these are all pretty short steps, just a few hours for each. I don't know if that's necessarily realistic. You can do it one line in 2 hours, but anyway, so it's pretty small there with the tasks. But as you can see here, this is our design development phase, or most of it. It actually was like way too long to fit on the page. But you can see here, we went in and we were adding in durations and making sure that the schedule actually lines up with the schedule that we had. So everything that you see here is actually following very closely to the dates for how we actually went through designing this project. And you can see that kind of at the end of every week on Fridays, we had a question and discussion time with Lundberg Engineering, and all of our speakers that came in are also listed on here. And you can see here, this is the Gantt chart for that. And you can see the resources that we used here. So anytime we had somebody coming to speak, like here's one from Cutler Hammer, here's Lundberg Engineering coming in to answer questions for us. So we were able to put all the resources in for that. And obviously, I'm on every single one because I was the one doing the design for it. And then here is our construction phase of the project. You can see broken into subtasks. We have like a rough-in phase for the switchgear and the LV systems and our power and lighting. And then we had a few construction crews, or electrical crews working on this. I think we had 3 electricians and 6 apprentices. So it was 3 separate teams working on it. And so when we allocated the resources, we had to make sure that everything sort of works together. So if one crew gets done at a certain time, I mean, trying to make sure they're not overlapping anything and making sure that everything's coordinated throughout the project. So let's look at the Gantt chart during the construction phase. And then at the end, we just have the project delivery, delivering the finished product to the customers, do a final walkthrough with the owner, and then we get the customer approval. So you can see that's a milestone there showing, the end of, like here's the end of the construction phase, and then another milestone saying the project has been approved by the customer. So here's another look. This is my mechanical room. It looks a little bit different than Adam's. We all kind of had a chance to try to place things in the room how we felt it fit best. We didn't do any coordination with any other contractors, so we don't necessarily know where the ductwork and everything was. But as you can see here, I have my air handling unit. And it's powered through a variable frequency drive. That's going to go straight over to our main panel. And then the 2 boiler pumps next to the gas boiler, and those both have a disconnect on the wall. It's going to be circuited straight to the main panel. And then we have the gas boiler, which just has a control circuit that is powered from the receptacle panel. And then we have the main panel here being powered from the auto transfer switch, which goes outside to the generator and to the utility. And then the receptacle panel and the lighting panel, which are both connected to the main panel. And this right here is just a horizontal unit heater that's up on the ceiling, and that is powered from the receptacle panel, I believe. And then here's a look at some of the mechanical equipment outside. These are just our air conditioning condensing units. This is the one that is going to be existing, and then we also had a plan for a future one. The disconnects are mounted right on the side of these. So now we're going to talk a little bit about the power layout. As you can see here, this is our main open office area, and these right here are cubes along the wall. And so when we were putting the power in these, we basically just had to plan for one receptacle in each office for general use, and then a quadruplex receptacle for data. And these are our island cubes that were in the main open office. And each one of these just has a three-phase junction box coming out of the floor, or 3 poles, and you'll basically be coming out of this junction box with a snake and running it through the cubes. We actually got a chance to look at that when we toured Lundberg, and I was glad to know that I did it right. Confirmed that when we took a look at it, so it's interesting to walk around their building and see how everything you did matches up with what's in their building, and some things obviously turn out a little bit differently. So here's a look at just a few of the offices and conference rooms. As you can see, this here is a pretty standard office layout, one receptacle on each wall, plus a quadruplex receptacle for data. And then this is a conference room, has a junction box for power underneath the conference room table, and then again an outlet on each wall for general use and a data outlet, which is quadruplex receptacle. This is our front entry and reception area. You can see there's a cabinet unit heater that is powered from the receptacle panel sitting in the vestibule, and you can see the receptacle layouts that we had here. This is the edge of the conference room right there, and the edge of the office. And then right here is our hallway. As you can see, we had receptacles spaced out in there. This is our other open office. It's just kind of a straight line of cubes along each wall, and it's going similar to the other open office, just a data receptacle and a general use receptacle each in each cubicle. In our restrooms, we have one single GFCI located above the counter. And this is the kitchen. You can see here, general use receptacles kind of on each wall. We had separately circuited outlets for the refrigerator, vending machine. This is the coffee maker, and then a microwave and a dishwasher is powered from a direct connection through the floor. And then this here is a quadruplex receptacle mounted up near the ceiling for a television to be connected. Now we'll take a look at the mechanical panel schedule. This was done using Revit as well. So for the main panel, we use a 500 amp panel, and it is a 12208 3-phase 4-wire panel. And as you can see here, this is basically what the circuiting looks like for us when we came in. Obviously a 3-phase schedule. And you can see the receptacle panel, air handling unit are connected on here. That's showing your demand load for each one. For the panel totals, I ended up getting a total estimated demand of 282, total connected load of 313. And then when we planned for future sizing and future expansion of the building, we ended up getting a 500 amp panel. The receptacle panel, very similar. This one ended up being a 100 amp panel, 12208. You can see how the circuit goes on here. Also 3-phase. Some things like the floor box is connected